THHN wire is a common choice for wiring in a negative 40-degree freezer environment. THHN stands for thermoplastic high heat resistant nylon coated. This type of wire is popular due to its versatility, cost effectiveness, and resistance to heat, moisture, and abrasion. However, it's essential to understand its limitations, especially in extremely cold temperatures. The primary concern when using THHN in a freezer is its flexibility at low temperatures. While the thermoplastic insulation can withstand a wide range of temperatures, it can become brittle and less flexible in extremely cold conditions. This reduced flexibility can make installation more difficult and increase the risk of cracking or damage to the insulation if the wire is bent or stressed. While the wire itself can function electrically at negative 40 degrees, the reduced flexibility of the insulation presents a mechanical challenge. Therefore, when using THHN in a freezer, it's crucial to handle the wire carefully during installation, avoiding sharp bends or excessive stress. Consider using strain relief methods to prevent any stress on the wire connections. It's also important to ensure that the wire is properly supported to prevent sagging or movement, which could further stress the insulation. In some cases, it may be beneficial to consider using a cold weather rated wire specifically designed for extremely low temperatures. These wires typically have insulation materials that remain flexible and resistant to cracking even at negative 40 degrees and below. Examples of such wires include those with silicone rubber or cross-linked polyethylene insulation. These materials are designed to maintain their flexibility and integrity in harsh environments. The National Electrical Code, or NEC, provides guidelines for selecting and installing electrical wiring in various environments. While the NEC doesn't specifically address wiring in freezers, it does provide general requirements for wiring in damp, wet, and corrosive locations. These requirements may be applicable to freezer installations depending on the specific conditions. Article 300.7 of the NEC, for example, addresses the spread of fire and products of combustion. When installing wiring in a freezer, it's crucial to ensure that the wiring method and materials used do not contribute to the spread of fire or release hazardous fumes in the event of a fire. Article 310 of the NEC covers conductors for general wiring. This article provides information on conductor ampacity, insulation types, and installation requirements. When selecting THHN wire for a freezer application, it's essential to ensure that the conductor size is adequate for the circuit's load and that the insulation is suitable for the environment. Article 334 of the NEC covers non-metallic sheath cable, commonly known as Romex. While Romex is often used for residential wiring, it's generally not recommended for use in freezers or other damp or wet locations. This is because the paper or fiber fillers in Romex can absorb moisture, leading to corrosion and electrical problems. Article 392 of the NEC covers cable trays. Cable trays can be used to support and route electrical cables in commercial and industrial applications, including freezers. When using cable trays in a freezer, it's essential to ensure that the cable tray material is compatible with the environment and that the cables are properly supported and secured. In addition to the NEC, other standards and guidelines may be applicable to wiring in freezers, depending on the specific application and local regulations. For example, the underwriters' laboratories, or all, develop standards for electrical products, including wires and cables. UL-listed wires and cables have been tested and certified to meet specific safety and performance requirements. When selecting THHN wire for a freezer, it's recommended to choose a UL-listed product to ensure that it meets industry standards. The Institute of Electrical and Electronics Engineers, or IEE, also develops standards related to electrical engineering. IEE standards may provide guidance on wiring practices and safety requirements for specific applications, such as industrial freezers. Furthermore, it's important to consider the specific requirements of the freezer manufacturer. The manufacturer's instructions may specify the type and size of wire that should be used for the electrical connections. Following the manufacturer's recommendations is essential for ensuring the safe and reliable operation of the freezer. In summary, While THHN wire can be used in -40-degree freezer environments, it's important to be aware of its limitations and take appropriate precautions. Firstly, consider the reduced flexibility of the insulation at low temperatures and handle the wire carefully during installation. Secondly, ensure that the wire is properly supported and protected to prevent damage. Thirdly, consider using a cold weather-rated wire specifically designed for extremely low temperatures if the application requires greater flexibility. Finally, consult the NEC UL standards and the freezer manufacturer's instructions for guidance on selecting and installing electrical wiring in freezers. By following these guidelines, you can ensure that the electrical wiring in your freezer is safe, reliable, and compliant with applicable codes and standards. When working with electrical wiring, it's always important to prioritize safety. Always disconnect the power before working on any electrical circuits. Use appropriate personal protective equipment such as gloves and safety glasses. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to prevent accidents and injuries. Properly installed and maintained electrical wiring is essential for the safe and reliable operation of any freezer. By understanding the properties of THHN wire and following best practices for installation, you can ensure that your freezer operates efficiently and safely for years to come. When selecting THHN wire for any application, it's important to consider the voltage and amperage requirements of the circuit. The wire must be sized appropriately to handle the expected load without overheating. The NEC provides tables and guidelines for determining the appropriate wire size based on the ampacity of the circuit. For example, NEC Table 310.15b16 provides ampacity ratings for various conductor sizes based on insulation type and ambient temperature. It's crucial to consult this table to ensure that the wire you select is adequate for the application. In addition to ampacity, it's also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a long wire run is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to use a larger wire size or shorten the wire run. When installing THHN wire, it's important to follow proper wiring practices. Use appropriate connectors and terminals to ensure a secure and reliable connection. Avoid over-tightening screws, as this can damage the wire or the terminal. When splicing wires, use approved splicing methods, such as crimp connectors or wire nuts. Ensure that all connections are properly insulated to prevent short circuits. When running THHN wire through conduit, use a wire lubricant to reduce friction and make it easier to pull the wire. Be careful not to damage the insulation when pulling the wire through the conduit. Support the conduit properly to prevent sagging or damage. When terminating THHN wire equipment terminals, follow the manufacturer's instructions. Use the correct torque when tightening screws or bolts. Ensure that the wire is properly seated in the terminal to prevent loose connections. After completing the wiring, test the circuit to ensure that it's working properly. Use a multimeter to check the voltage and current. Verify that all equipment is operating as expected. If you encounter any problems, troubleshoot the circuit to identify and correct the issue. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical wiring. Inspect the wiring periodically for signs of damage or wear. Check for loose connections, corroded terminals, or cracked insulation. Repair any problems promptly to prevent further damage or safety hazards. Keep the wiring clean and free from dust and debris. Dust and debris can accumulate on the wiring and cause overheating or insulation breakdown. If you're not comfortable performing electrical maintenance, hire a qualified electrician to do the work. Remember that electrical maintenance can be dangerous, and it's important to take all necessary precautions to prevent accidents and injuries. By following these guidelines, you can ensure that your THHN wiring is properly installed, maintained, and operating safely and efficiently. When considering alternatives to THHN wire for cold environments, several other options are available, each with its own advantages and disadvantages. One alternative is XHHW wire, which stands for cross-linked polyethylene high heat resistant, water resistant. XHHW wire has a higher moisture resistance than THHN wire and is often used in wet locations. It also has good flexibility at low temperatures, making it a suitable choice for freezer applications. Another alternative is THWN wire, which stands for thermoplastic heat and water nylon. THWN wire is similar to THHN wire, but has a higher water resistance. It's often used in damp or wet locations where THHN wire is not suitable. However, THWN wire may not have the same low temperature flexibility as XHHW wire. Silicone rubber insulated wire is another option for cold environments. Silicone rubber remains flexible at extremely low temperatures, making it an excellent choice for freezer applications. However, silicone rubber insulated wire is typically more expensive than THHN, THWN, or XHHW wire. Teflon insulated wire is another option for extreme temperature applications. Teflon has excellent resistance to heat, cold, and chemicals. However, Teflon insulated wire is also more expensive than other types of wire. When selecting a wire for a freezer application, it's important to consider the specific requirements of the installation. Consider the temperature range, moisture levels, and potential for exposure to chemicals or other harsh substances. Also, consider the cost and availability of different types of wire. Ultimately, the best choice of wire will depend on the specific application and the trade-offs between cost, performance, and reliability. When working with electrical wiring in a freezer, it's important to be aware of the potential for condensation. Condensation can occur when warm, moist air comes into contact with cold surfaces. The condensation can cause corrosion of the wiring and electrical components. To minimize condensation, it's important to seal all openings and penetrations in the freezer enclosure. Use appropriate sealants and gaskets to prevent air leaks. Also, consider using a dehumidifier to reduce the humidity levels inside the freezer. In addition to condensation, ice can also accumulate on the wiring and electrical components in a freezer. Ice can damage the wiring and cause electrical problems. To prevent ice accumulation, it's important to keep the freezer clean and free from frost. Defrost the freezer regularly to remove any ice buildup. Also, consider using a heater to keep the wiring and electrical components above freezing. When installing electrical wiring in a freezer, it's important to consider the potential for mechanical damage. Freezers are often used in industrial or commercial settings where they may be subject to rough handling. To protect the wiring from mechanical damage, it's important to use appropriate wiring methods and materials. Use conduit to protect the wiring from impact and abrasion. Support the conduit properly to prevent it from being damaged. Also, consider using flexible conduit to allow for movement and vibration. In addition to mechanical damage, electrical wiring in a freezer can also be damaged by rodents. Rodents can chew on the wiring and insulation, causing short circuits and other electrical problems. To protect the wiring from rodents, it's important to use rodent-resistant wiring methods and materials. Use metal conduit to prevent rodents from chewing on the wiring. Seal all openings and penetrations in the freezer enclosure to prevent rodents from entering. Also, consider using rodent repellent to deter rodents from entering the freezer. By taking these precautions, you can protect the electrical wiring in your freezer from damage and ensure its safe and reliable operation. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to prevent accidents and injuries. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work.